Hello GATE aspirants, welcome to part 13 of GATE Electromagnetic Theory series. Question number 15. On the surface of a spherical shell enclosing a charge-free region, the electrostatic potential values are as follows. One quarter of the area has potential phi naught, another quarter has potential 2 phi naught, and rest has potential 4 phi naught. The potential at the center of shell is. Now phi average we can calculate. So 1/4 has phi naught plus 1/4 has 2 phi naught, and rest will be 1/4 is half, so rest will be half, and for it is 4 phi naught. So this will be equal to 1/4 plus 1/4 plus this will be 1/4, so that will be totally it will be 11/4 into phi naught. So option A is correct. Next question. A point charge Q is performing simple harmonic oscillation of amplitude A at an angular frequency omega. Using Larmor's formula, the power radiated by the charge is proportional to. Now Larmor's formula gives power radiated by a non-relativistic accelerating point charge, and that is equal to P is equal to Q square A square upon 6 pi epsilon naught C cube. And here it is given that it is performing simple harmonic motion. So A is equal to acceleration is equal to minus omega square into x. That means A max it will be equal to omega square into A, capital A, which is amplitude. So we can substitute it here. So P from here we can see it will be proportional to charge is Q square. The denominator is constant only. 6 pi epsilon naught C cube is constant. So in the numerator we have Q square into acceleration is omega square A square. So this is proportional to Q square omega raised to 4 and amplitude raised to 2. So here option D is correct. Next question. Electric field is measured along the axis of uniformly charged disk of radius 25 cm. At a distance d from the center, the field differs by 10% from that of an infinite plane having the same charge density. The value of d is in centimeter, round off to 1 decimal place. Now electric field due to sheet is equal to sigma upon 2 epsilon naught, and electric field due to disk is equal to, if you are considering a disk of radius r and if you are considering at a distance some d, then this angle will be theta, then E disk is equal to sigma by 2 epsilon naught into 1 minus cos theta. So this will be equal to sigma upon 2 epsilon naught into 1 minus cos theta is equal to adjacent is d upon this will be r square plus d square. So this will be electric field due to disk. Now it is given that difference between these two is 10% of electric field of sheet. So 10% of electric field due to sheet. So this will be equal to, that means this is 10% of E sheet, that means this will be 0.1. So that will be 90%. So from here we can see electric field due to disk is 90% of electric field due to sheet. So that means sigma upon 2 pi epsilon naught in bracket 1 minus d upon under root r square plus d square is equal to 90% of. So that is 0.9 into sigma upon 2 epsilon naught. So this will cancel on both sides. So this is 1 minus this. So that is 0.1 is equal to d upon under root r square plus d square. Taking square on both sides, so this will be 0.01 into r square plus d square is equal to d square. So r square plus d square is equal to, this will be 100 of d, 100 into d square. So that is r square is equal to 99 into d square. So d is equal to r upon under root 99. But r is given 25 centimeter upon under root 99. Under root 99 is roughly under root 100. So that is 10 only. So this will be 2.5 centimeter. So answer is 2.5 and answer given in the answer key is 2.4 to 2.6. Next question. A parallel plate capacitor with spacing D and area of cross section A is connected to a source of voltage V. If the plates are pulled apart quasi-statically to a spacing of 2D, then which of the following statements are correct? First is the force between the plates at spacing 2D is this. So let us first calculate that. We have initially this capacitance that is equal to epsilon naught A by D. If the spacing is changed, then capacitance will change. So epsilon naught A by 2D will be new capacitance. Now force is equal to Q square by 2 epsilon naught A. So next force, here force will be Q2 can be written as Q can be written as C into V. So here capacitance is C2. So C2 into V square upon 2 epsilon naught A. So that is equal to V square by 2 epsilon naught A and C2 is epsilon naught square A square upon 4D square. So from here it will be 1 by 8 epsilon naught here A into V square upon 8D square. So that will be the force. So that means option A is correct. Now for option B, work done is equal to change in potential energy. So that is equal to half of C1V square minus half of C2V square. So this will be 1 by 2 into V square. C1 is epsilon naught A by D minus C2 is epsilon naught A by 2D. So work done is equal to 1 minus half, that is half. So half into half is 1 by 4 epsilon naught A by D into V square. So this is wrong. Here we are getting 1 by 8 here. So option B is wrong. Option A is correct. Then for C, energy transferred to the voltage sources. Now if the plates are pulled apart quasi-statically, that means the entire energy of the capacitor becomes available to be transferred to the voltage source. So complete energy will be transferred to it and initial energy is Ui is equal to half into Cv square, so epsilon naught A by D into V square. So this entire energy can be transferred. So option C is correct. Now option D is energy of the capacitor reduces by. The energy of the capacitor reduces, that will be equal to work done. So work done is this 1 by 4 epsilon naught AB square by D. So that means option D is correct here. So option A, C and D are correct. Next question. A plane polarized electromagnetic wave propagating in YZ plane is incident at interface of two media at Brewster's angle. Take Z is equal to 0 as the boundary between the two media. The electric field of the reflected wave is given by. This expression is given, then which among the following statements are correct? This is E of R and it is in x cap direction. So from here k bar is equal to, this is k naught root 3 by 2 into this y. So that is y cap minus we have k naught into 1 by 2 into z cap. So this is k bar. So from here we can write tan theta. Tan theta is equal to ky by kz and that is equal to root 3 by 2 upon 1 by 2. So that is root 3. So that is value of tan theta. So if it is tan theta, then theta b is equal to pi by 3. So angle will be pi by 3. So from here we can calculate angle of refraction. Pi by 3 is 60 degree. Now angle of incidence theta b plus angle of refraction theta r plus 90 degree, that is equal to 180 degree because they are perpendicular to each other. So that means from here theta r is equal to, This will be 90 plus 60 minus 180. So from here you will get 30 degree, which is pi by 6. So option A is correct. It will be pi by 6. Option B is ratio of permittivity of medium of refractive index epsilon 2 with respect to 1 is this. Now from here we can calculate tan theta b is also equal to n2 by n1, and n2 can be written as epsilon r2 mu r2 upon under root epsilon r1 mu r1. So this will be equal to root of 3 because mu r1 mu r2 are same, and this is 3 1. This is root 3. So from here under root epsilon 2 by epsilon 1 is equal to root of 3, that gives us epsilon 2 by epsilon 1 is equal to 3. So option B is correct. Now for the option C, incident wave can have components of its electric field in YZ plane. So that is not correct. And for option D, angle of refraction is pi by 6. So this is also not correct. Okay, for the C, it is given that incident waves can have components in the electric field in YZ plane. And we have calculated K here, so it is along YZ plane. So yes, it is correct. Incident wave can have components in its electric field in YZ plane. Next is question number 65. A current of 1 ampere is flowing through a very long solenoid made of winding density 3000 turns per meter. As shown in figure, a parallel plate capacitor with plates oriented parallel to the solenoid axis and carrying surface charge density 6 epsilon naught is placed at the middle of the solenoid. The momentum density of electromagnetic field at the midpoint x of the capacitor is n into 10 raised to minus 13. The value of n is. Here this is a solenoid, so magnetic field inside, that will be equal to mu naught into nr, and electric field inside that capacitor will be sigma by epsilon naught. Now we have to calculate momentum density. Momentum density, let it be PD, that will be equal to 1 by c square into s, where s is Poynting vector. So this will be 1 by c square. Basically s is energy, so this will be energy is pc square that we are using here. S is 1 upon mu naught EB. So this will be 1 by c square into mu naught into E will be sigma by epsilon naught into mu naught nr. So this mu naught will cancel out. So this is, and also we have here C, so we will adjust for it. So this will be equal to, this sigma is equal to, it is given 6 into epsilon naught upon c square epsilon naught into we have n into I. So this epsilon naught will cancel. So 6 into n, number of turns is given, that is 3000. So 3 into 10 raised to 3, and current is 1 ampere upon we have 3 into 10 raised to 8 square. So this will be 6 into 3 by 9. So that is 2 into 10 to the power minus 16, and this is 3. That is minus 13. So answer is 2, and answer in the answer key is 2 to 2. So these were all the questions from GATE 2022 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.